All right, today we are pulling back the curtain on AI voice assistants. We're going to break down the exact architecture you would need to build your very own, starting with the big ideas and getting all the way down to the specific models that make it all tick. So yeah, let's dive right in. Have you ever been talking to a voice assistant and just thought, how does this thing actually work? Could I build one of these myself? Well, the short answer is yes, you absolutely can. And by the time we're done with this explainer, you're going to have the blueprint for how to do it. So the entire foundation of any conversational I don't care if it's the simplest one or the most complex one on the planet, it's all built on one single fundamental concept, and it's called the voice loop. The easiest way to think of the voice loop is as the engine. It's this constant, nonstop cycle that takes in sound, understands it, thinks of a reply, speaks that reply, and then boom, it's immediately listening again. It's that continuous flow that creates the illusion, that feeling of a real conversation. So let's break that engine down into its 5 parts. First, the microphone grabs your voice. That audio then gets converted into text. That's called speech to text. Then, that text is sent to the AI's brain, the large language model, to figure out a response. The model's text response then gets turned back into audio via text to speech. And finally, it's played through the speaker. And the second it's done talking, the whole loop starts right back over again. Okay, so once you understand the voice loop, you immediately run into the single biggest decision you have to make. Where does the thinking actually happen? Do you use the unbelievable power of the cloud, or do you keep everything completely private and on your own device? This is the core dilemma. And this leads to some pretty clear trade-offs. On the one hand, using the cloud is crazy fast, it's simple to set up, and there's almost no upfront cost. The catch? Your data is being processed by someone else, and you always need an internet connection. On the other hand, a local, on-device model gives you total privacy, and it can work offline. But it requires a big investment in hardware, and it ends up being a lot slower. It really feels like you're forced to choose. Do you want speed, or do you want privacy? So, which way do you go? Well, for a voice assistant to feel natural, to feel real, one thing matters more than anything else: speed. Any weird pause or awkward delay just completely shatters the illusion and makes the whole thing feel broken. So the number one priority is we have to solve for speed. And when it comes to pure, raw speed in the cloud, one model has really been singled out. It's called Gemini 1.5 Flash, and people are calling it the speed champion for a very good reason. And here's that reason: 372 tokens per second. Now, a token is roughly one word. This is just an incredibly fast rate of generation, and it's built specifically for the kind of low-latency, real-time chat that a voice assistant has to have. Let's really put that in perspective. A common setup for a local, do-it-yourself project would be something like a Raspberry Pi 5. You can run a small AI model on it and get about 8 tokens per second, which for a tiny little computer is actually pretty impressive. But compare that to Gemini Flash in the cloud. It's not just a little bit faster, it's over 45 times faster. That performance gap is the difference between a frustrating experience and, well, a magical one. So it feels like we're stuck, right? We need the speed of the cloud, but we want the privacy of a local device. What if we didn't have to choose? This is where the hybrid model comes in. It's a really elegant solution that promises the best of both worlds. Now, the hybrid model isn't just some messy compromise. It's a super strategic design. The idea is to take the unbeatable speed from the cloud and the absolute privacy from a local device, put them together, and get rid of their biggest weaknesses in the process. So here's how it works, and it's beautifully simple. You have a small, very efficient AI that runs locally on your device. Its only job is to listen for a wake word, like, "Hey Gemini." It is not recording everything. Only when it hears that specific phrase does it wake up the main system and call the powerful cloud AI to handle the real conversation. The best way to think about it is this: your local device is like a privacy-conscious gatekeeper. It keeps the door to the internet closed. All the background noise in your house, private conversations, none of it ever leaves your device. But when you say the magic word, the gatekeeper opens the door just long enough for you to talk to the powerful cloud supercomputer, and then it shuts it right away. So why is this hybrid approach the clear winner? Well, it really comes down to 3 things: performance, privacy, and maybe surprisingly, price. Look at what you get. You get the amazing performance of the cloud, so your conversations feel totally fluid. You get enhanced privacy, because your device is only really listening when you want it to. This also dramatically cuts down on costs because you're not constantly streaming data. And crucially, for anyone building this at home, you avoid that huge upfront cost for powerful local hardware. So, what does all this cost? For a typical hobbyist, let's say having about 20 back and forth conversations a day, the estimated monthly cloud bill is just 45 cents. That's it. That's the price of getting world-class AI speed without a massive hardware investment. It's kind of nuts. Okay, this all sounds fantastic, but there's one little technical question that might still be nagging at you. We said a small AI runs on the local device. But how do you actually fit a powerful AI model onto a tiny piece of hardware like a Raspberry Pi? The answer is a really clever trick called model quantization. In simple terms, it's a process that makes an AI model much, much smaller and more efficient by basically reducing its numerical precision. Think of it like compressing a huge high-resolution photo into a smaller JPEG. You lose a tiny bit of detail you'd never notice, but the overall picture is the same, and the file size is way smaller. That's what makes running that little gatekeeper AI on your device possible. So there you have it. The secret isn't choosing between the cloud and a local device, it's using a smart hybrid model. You use a quantized local AI for privacy and a powerful cloud AI for speed, and you can do it all for less than $1 a month. The architecture is no longer a mystery. The only question left is, what are you going to build with it?